Hi, this is your host Chantel, and I welcome you to 5 and 5 Live, where we interview experts on various advanced technology programs, inventions, and developments. Our format is 5 questions, 5 answers in 5 minutes. At the end of the interview, we provide additional information. So let's get started, and thank you for watching 5 and 5 Live.
Hi, Caden Stanzione here with Dr. Daniel Schrage, who has a long career in vertical lift aviation. He's a U.S. Military Academy graduate, a Vietnam helicopter pilot, and he's been instrumental in the development of military helicopters and vertical lift aircraft and supporting technologies. He's the founding executive director of the Centers for Rotorcraft Excellence, which is now the Vertical Lift Research Centers of Excellence at Georgia Institute of Technology, and he's currently leading initiatives in certified autonomy for VTOL aircraft. I've had the pleasure of working with Dr. Schrage and learning from him for 40 years. It is so nice to have you join us today, Dr. Schrage, on 5 and 5 Live, so let's get started.
Okay.
First question. What do you think is the most significant development in VTOL technology to date?
Well, I think the big thing is that VTOL were usually complex mechanical systems, but over the years, more and more the integration of software and avionics, and in today's environment now, hybrid, electric, and I think that plays a very big role in the future vertical lift aircraft. And the idea for autonomy is becoming very important because as you make it more and more software oriented and things like that, you're going to have to be able to use adaptive controls, for instance, as part of the safety and certification. So I think there's a big opportunity there, but it's quite a bit of a change from what people are used to treating mainly complex mechanical systems. That's still a critical part of it, but we really got to identify software and integration of avionics and safety and certification is going to be a bigger role.
I think we all agree with that, and we know you're doing a lot of work in there. So what are some of the challenges facing FAA certification of autonomous flight control systems?
Well, I think the big thing is, the FAA has been very conservative over the years with safety and certification, and I think maybe the Europeans have been moving a little bit faster, especially in regards to VTOL, electric VTOL and hybrid and things like that. But I think the big thing is the thing that's made successful for civil aircraft has been the idea of developed assurance or development assurance. And what they're realizing now is to really enhance that, you have to move to things like hybrid and that, and there's really a need for what's called runtime assurance, so that you can use software adaptive control to keep you within the flight envelope, and that's where artificial intelligence and machine learning comes in, and autonomy comes in, because of the fact that you're not going to be able to take these very complex functions, whether they be machine learning or artificial intelligence. You're not going to have complete confidence in them, so you're going to have this idea of adaptive control to keep you flying in a safe flight envelope. So autonomy is going to play a role, but it's still going to be a big challenge to be able to figure that out.
I agree. And when operating any aircraft, any system, some of the key considerations come into direct operating cost. A big piece of that direct operating cost is obviously the maintenance, the mean time between failures, mean time between repairs. I know you've been doing a lot of work in maintenance-free operating period technology. So what are the key considerations you see in developing MFOP technology for the near future?
Well, it goes back. I've been involved with helicopters for about 40, 50 years. And the operation and support, the operational availability, they're very complex machines. And as a result, when the Army, they always wanted an operational availability of about 90%. But in reality, you take the Apache or take any of these complex helicopters, they end up with about 70%, 75%. And as a result, that becomes a big concern because so much of the money is spent on operations support to do that. There's been some lessons learned over the last 20, 30 years where if you can set an operational availability goal, whether it be 90%, but you got to figure out how you're going to do that. If you use things like maintenance-free operating period, you have an opportunity to kind of schedule that in such a way and then show confidence. You see, that confidence to achieve that 90% availability means that whatever you come up with for a maintenance-free operating period, whether it's 10, 12, 30, 50 hours, you're going to have confidence in 90% that you can do that, because that's the thing that's going to really drive the safety of it. So I think we brought this up. Actually, Dr. Bill Lewis had a goal for the future vertical lift to make zero maintenance. And I went to a conference up in Aberdeen, and I introduced these guys. I said, "There's no way you're going to get zero maintenance, okay? But here's a methodology that allows you to do that." And so pretty much they hopped on that. The future vertical lift now uses this idea of maintenance-free operating period, but it takes some understanding and some training to do that because basically they want it like 500, 700 hours, where that's completely unrealistic. So we actually did a program for him, and now one of my Ph.D.s, Lieutenant Colonel Andy Beluccio, is up at the Military Academy, and he runs a center there that the Army funds to help them try to advance this maintenance-free operating period and get it into the fleet of aircraft. So I think there's some real opportunities there, but it's really a puzzle to figure out how to do that, and you really got to have ways of doing it. And I think that's coming about now. In the civil sector, there's quite a bit of that work done. It's not always on aircraft, though. It's done on ships and other things, and they've kind of moved in that direction as well. So I think maintenance-free operating period, especially for things that are going to have to operate 10, 12, 15, 20 hours without any maintenance, you can't physically do that today. You can't take any helicopter we got, whether it's a Black Hawk or the Navy with the V-22. There's no way they can fly these things maintenance-free for more than about 5 hours.
Right.
And so to get to 10 or 12 or 15, people have to use this approach.
Well, it's surely going to change the way our future vertical lift aircraft are being designed in terms of how they're going to operate, getting away from a phased maintenance program, such as what's on the current Black Hawk today and many other military weapon systems. So that is something that's going to play a major role, MFOP, going forward. I agree. You know, another major program that I know you have been working on is in the Modular Open Systems Approach, MOSA. And that has become a requirement for military aircraft. But I guess the question really is, how can MOSA be adopted for commercial aircraft OEMs going forward?
Well, I think the thing about MOSA, I've been through these before. Back in the 1990s, we learned from the Japanese a little about total quality management, concurrent engineering, and then we went to the Army required idea of integrated product and process development. And so we picked that up at Georgia Tech, and in fact that became a focus of our Vertical Lift Center and our Aerospace Systems Design Lab, was to basically build off of that. And the thing that I've been pushing for the last 5 or 10 years is that we have to go to open system architectures. And in the avionics sector, they're kind of leading the pack on that because of the fact that if you look at the cost of, like different aircraft and everything, an awful lot of the cost goes into what they call, I can't think of the name of it right now, but it really takes a lot more maintenance and operating costs than you have. So I think this idea of open system architecture is good, but the idea that it started off being open system architecture, then it was modular open system architecture, and now it's called Modular Open System Approach. And unfortunately, that's sort of when people don't really know how to do it, they say we're going to do an approach. And if you watch the Army right now and the other services, they're trying to implement this, modular open system approach. But they really got to understand that, like safety and certification, there's already this integrated modular avionics approach. And so they're kind of changing that way. I know that the Army has got a credo with Collins Aerospace now to try to show them how they might use this modularity and try to apply it that way.
Very good. Thank you. So wrapping up on our fifth question, you've been involved in education, many Ph.D. students, both on civilian sector as well as a lot of the military coming through Georgia Tech. Looking back, and then of course now looking forward, what should aerospace engineering schools like Georgia Tech be teaching today to better prepare their students for the industry of tomorrow? Since our transformative VTOL aircraft of tomorrow are a drastic departure from current design thinking, what can we do at the university level today to produce the student body necessary for tomorrow?
Well, a lot of that came when I arrived at Georgia Tech in 1984. I'd just gone through the development of most of the Army aircraft and saw what a lot of the problems were. And like I said, it needed to include a better design approach. And the design had to be more than conceptual, because when you have complex systems like helicopters and advanced VTOL, you have to bring in a lot more of the disciplines. So we actually started a graduate program. We had the Vertical Lift Research Center of Excellence. And I think Maryland, I think Penn State and RPI, they all kind of followed that. But if you look at the student design competitions from 1985 to about 1994, we won like 90% of them. And part of it was because we were trying to apply this kind of concurrent engineering approach and do it that way. So that worked out well. But we've expanded it. We used the vertical lift and rotorcraft as a test case. And then with Dr. Dimitri Mavris, who was a student of ours there, we set up the Aerospace Systems Design Laboratory. And now if you look around the world, it's probably the leading program, the largest program in the world, because it does fixed wing. We just had a Ph.D. this morning that was working with NASA Langley on safety and certification for uninhabited aircraft and stuff like that. So I think there's some things to do. I've been a little bit disappointed because when I was there, we had built all this up. But it's typically in a university, sometimes you get faculty want to do different things and different specialties. And so my third book that I'm writing right now is how we set up the graduate program in aerospace systems design, but also how hard it is to sustain it, you see, because you get different faculty that have different interests and stuff like that. And I know we brought the space side into the house, and that seemed to work pretty good for a while, but then they all left and went different things. And now the spacecraft guys, I don't think, pay that much attention to it. So it's the universities can play a much bigger role than people think. You know, a lot of times they think universities are just doing basic research. But if you're an engineering program like Georgia Tech and Maryland, some of these other schools, you should be doing more than just the basic research. I mean, some faculty don't like that because I think about half the faculty are probably scientists as opposed to engineers. So to them, they don't really understand engineering. And probably the engineers don't understand the science part of it sometimes too. But I think the universities can play a much bigger role. And we tried to do that, but it's a continuing thing that you have to try to sustain.
I totally agree with you, Dr. Schrage. Many years ago, I wrote an article for the Journal of Applied Engineering Education, where we basically said you have to teach your students the skill sets that can be used immediately in industry, so that there's not this, detention, there's latency time where a student comes into the industry and can require years to develop the skill sets necessary. So I do appreciate your time with us here at 5 and 5 Live. For those of you, Dr. Schrage mentioned his books. It's actually a trilogy. You'll be able to get more information on how to get these books. The first book is out. The second one should be out shortly. And we'll give you some links on how you can acquire the books. So Dr. Schrage, thank you very much. And we'll see you at the upcoming forum.
All right. Thank you.
Thank you for watching 5 and 5 Live. We hope you found the interview to be informative and that it has met your expectations. Please visit our website for any additional information the expert has made available for download. Also, While at our website, if you have an exciting product, research, or business that you would like to share with our audience, please let us know. We would love to hear from you. Thank you and goodbye.